When it comes to user management and more specifically creating users in Linux, the text file that gets modified is the etc password file. And then when you set the actual password for the user, then the etc shadow gets modified. So let's take a look at these files. First, let's see the etc password. Okay. Here in the etc password, you will find an entry for each user, and each of the parameters on the entry are separated by a colon. The first parameter is the name of the user account. So in this case, it's called NIS student. The second one is actually the password, but in most Linux systems, most modern Linux systems, um, we use what is called a shadow password. And what that does is instead of putting the hash of the password on the etc password file, which is readable by every user in the system, we put that password in the etc shadow, which is only readable by root. That way, some regular user can go in and find the hash and try to break it. Then comes the user ID, then comes the group ID. Each user has a unique user ID, and then it belongs to a primary group, which has its own unique ID as well. Then there's a blank there, and then comes the home directory for the user, and then comes the shell that the user has been given. Um, so if you want to create a user, you have some options. You could either just create an entry like this in the etc password file, or you can use the command user add. User add basically all it does is it has different parameters to set each of these fields that we've talked about, and basically you can pass what these fields are. So you can pass the parameter to set the home directory to a particular one. You can pass a parameter to set this shell to whatever you decide, and then but at minimum it needs the name of the user account. So user add um, NIS user one would basically create this entry with the default user ID, and it will create uh, uh, a group with the same name as the user account. By default, it puts the account home directory in /home and the name of the account, and then bash is the default shell. Then when a user is created, there's a set of files that get put into the home directory, and these files are found in the etc scale folder. Um, so all of these files, which are shell files with environment variables and such, get put into the account once it's created and the user logs in. So if you create a user account and you log into the account, you will see these files. If you're a system administrator and you want to set some specific shell variables for the user so that when accounts are created, these are set, then you can modify these files, like the bash rc. If you're using the bash shell, you can edit that file in the etc scale and put all the variables that you need, and then that will be copied to the user's home directory, and then the user can go ahead and get those variables when they log in the first time. Um, the shadow password basically keeps the password hash, and let's take a look at it. Here, for example, for NIS student, we can see the hash, and then these fields here are the password expiration fields. And like I said, in most Linux systems we use shadow, so it basically just points to here to find that hash. But this file is only readable by root, so nobody can actually, a regular user can actually find what this is and try to break it. Um, Now, when it comes to groups, the file that we're concerned is the etc group file. So let's take a look at that. More etc group. In here, basically your group is just a group name and then the group ID. And then you can also set a password for the group, but we really don't do that. Um, and then to create a group, you could use the command group, add, and then you can do group add and then the name of the group. And then what that will do is it'll create a group with that name and it will give it an ID that's unique, the next one in line. Uh, there are commands out there that you can use if you've already created the accounts and you want to go in and edit some of these fields. You can go ahead and edit these files yourself, or you can use some commands out there, and I've listed a few of those on the notes and you can look at those to do that. But sometimes it's just easier to go into the etc password or the group file and just make the changes there directly. If you had a GUI interface and you were in run level 5, you can run the command system config users, which is basically the Red Hat user manager. And this gives you a really nice utility to create users and modify all this information, the expiration and passwords, the groups that the user belongs, the all kinds of information of all your users in your system. And again, you need a graphical interface. If I run it here, it's going to tell me that it requires X server, so I won't be able to run it. But sometimes it's also nice to do this from the command line if you don't have that, and modifying these files allows you to do that. So that's basically it for user management. The next thing I want to talk about is all of these files keep the user information locally. And one of the problems with that is that sometimes you have maybe 10 or 20 servers out there and you want to use a central repository for all the accounts. Instead of having accounts on each of these systems separately, you want a central repository where all users get that information from. And this can be done using the either LDAP or NIS. NIS stands for Network Information Server, and basically what it allows you to do is to create users on the NIS server and then configure your client workstations to point to that NIS server to find that information. It's very simple to do, and most Linux and Unix systems have used NIS for years. Nowadays, more people are turning into LDAP for this similar thing because LDAP is a little bit more secure and it's more widely used nowadays. But NIS is like the traditional way of doing this. So let's take a look at how we can go ahead and configure this workstation to be an NIS client and grab that information from an NIS server. What I'm going to do is I'm going to SSH into my virtual machine, and I'm going to make that virtual machine an NIS client to the server, which is CSE 570E. So what I need to do first is run the command system config authentication. This is basically a tool that if you have X Windows will run a nice GUI interface to let you configure this. The nice thing about it is that it also has a text-based piece which you can run from the terminal. So let's go ahead and run that. And here you can see it's the authentication configuration utility, and here you can tell it what type of authentication you want to do. Like I said, we can use LDAP or we can use NIS, or nowadays you can even do Winbind, which basically allows you to get the information from an Active Directory or Windows Active Directory. In my case, I want to use NIS for this example. We could easily do LDAP, but I have set up an NIS server, and it's basically the same concept. So here for authentication, we are using MD5 passwords. So when you saw that password for the account NIS student, you saw that long password, and that's actually an MD5 of the actual password. We're using shadow passwords. We're not using LDAP. We're not using Kerberos here. We're not using Windows, so we'll go to next. So we checked use NIS. So now we're gonna go to next. And when it comes to NIS, you need two things. You need a domain, for your NIS environment, and you need the server that's the NIS server. In our case, I've set up the domain to be in capital CSE 570E. And the server is actually nis.csc570e.edu, which is actually an alias in DNS to the CSE570E server. So I'm going to put that information and click OK. And basically what it's done, it's stop port map. NIS uses RPC commands to communicate, so you need the port map service, and it's basically stopped and then restarted the port map service. And then there are two more servers that need to be started. The first one is YP-bind. NIS used to be called the Yellow Pages, so YP-bind is it's the name of the client. So let me restart that with service YP-bind restart. As you see, it was already running when I did this system config authentication, so that's basically what it did. Port map has already been restarted. The only other one that's the only other service that you need that is useful is the YP passwords, or the Yellow Pages password. What this does is it allows you to change your password from the client side, and that changes it on the server, on the NIS server. So I'm going to start that one as well. So service restart YP pass WD. I think I misspelled that, so I'm gonna run it init.d YP path YP path. Oh, it doesn't look like it's installed in this machine, so we'll just skip that. That's an additional server, like I said, that allows you to sync your password, and we have to install the RPM for it, which is not installed currently, so we'll just skip it. At minimum, you just need port map and YP-bind, so that's what we have. So the next thing we want to do is run check config on these two services, so they start automatically next time we reboot our machine, so that we can continue being the NIS client. So we want to do a check config YP-bind on, and we want to do the same thing for port map. Now if we want NTSysV, we go to the bottom and we should see that YP-bind now has a check, so it will start automatically. So that's what we want. Port map would have the same thing. So now it looks like we are in good shape. I want to ping the NIS server just to make sure that DNS is configured correctly and it can resolve the host. So what we put in was nis.csc57e.edu, and it pings okay, so that's good. The next thing to do is to do an RPC info -p localhost to see all the RPC stuff that we have running. We have port map running, which is good, and we have YP-bind, so that's good. That's a good sign. So in order to test this, I'm gonna oh, before I do that, there's one more file that gets modified when we ran this command, system config authentication, and that file is the nsswitch.conf. Let's take a look at this file and I'll explain what it does. Basically, this file just tells the system where are you going to look for information for different things. So here, it's modified this file, and it's told it that for password, it's going to look in files first, which is the local database, and then if it doesn't find it there, it's going to go to NIS. The same thing for shadow, for the actual password, and the same thing for groups. Now, for some reason, it's also modified the host, so I don't want for hosts or for DNS information to go to NIS because I don't have any information right now there. So what I'm going to do is I'm going to comment that, and I'm going to tell it to look in files. So look in the etc host first for to resolve a host name to the IP, And if it can't resolve it from the etc host, then to go to DNS. And then everything else, I want files. So I don't want NIS for protocols. I don't want NIS for services. And I don't want NIS for auto mounts at this point. So basically, these are all the where your system looks for information for different components. And the ones that NIS are going to be helpful for us are passwords, the password information, which is the user username, user ID, shell, home directory, and that type of thing. Shadow, which is the actual password, and then group information as to what groups the user belongs to. So that's all we need in this file. So we're going to save it. And now we're ready to test this. To test this, there's a utility called getEnt. So we're going to run the utility getEnt, and then we're going to put password as the field that we want to check, and we want to check it for NIS student, which is actually an account that exists on the NIS server and not locally. So let's see if it gets it. See, and what it did is it went into a query the NIS server and it returned this information. And if you can see, we can do a grep for NIS student on etc password, and you will see that there is no entry. So it got this information from the actual NIS server. Another way to test this is to use a service like SSH. So we can do SSH NIS student at localhost, and then say yes, and then the password for NIS student, in this case I set it to student. So let's see if it lets me in. I put student, and it went ahead and created my and let me log in. What it's telling me here is that there is no home directory. So what I need to do on this system is create that home directory. So I'm going to do make dir home NIS student, and then chmod -r NIS student home NIS student to give the user access to that. What I meant to do was change ownership to make that user the owner of that directory. So now the NIS student owns that directory, and we can do ls -lah home NIS student and see that it's owned by NIS student, which is good. And then what I want to do is cp -rp etc scale star all the files there and put them in home NIS student. Dot star is what I want. So we'll copy all the files there. It's not copying, so let me go to that directory. And cp dot star into home NIS student. Okay. And that copies all that. I'm gonna overwrite those because I had already copied them. For some reason it didn't work the first time. So now we can do home NIS student and find all these files here, which I'm not sure why it copied all those files. I'm gonna remove those files. Okay, so now I have my bash stuff, which is what I wanted. The only thing left to do is to change the ownership. So chown -r NIS student dot on this directory. ls -lh, and now NIS student owns that, and that's okay. So now we can run our SSH command again. So SSH NIS student to localhost, the password is student, and this time it logged me in, but it's telling me that it cannot find the group ID 530. So let me look at that. I can run that getEnt command again. And look at that information. The NIS student belongs to group 530. So what I need to do is go back to my system, to my NIS system, which is this, and then grab 530 on etc group, and there is no 530. So what I need to do is do a VI on etc group, and 1500 is the group NIS students. So what I want to do is go to etc password and go to NIS students and put that user in 1500 for its group, and then make those changes take effect. And now we can test this again. So we'll run the SSH command too, and now we can see that the user belongs to group 1500, which is the NIS students group. So what I'm going to do is I'm going to do change ownership -r NIS student. NIS students is the group, NIS student is the user, NIS students is the group, and then the directory is home NIS student. Okay, ls-lh home NIS student, and we can see that we got the right permissions for all the bash shell configuration files. So now we should be able to run our SSH command. We'll SSH localhost as an NIS student, and the password is student. And we've logged in and we got no errors. So basically what this shows us is that with NIS we can get all the password information and shell information, home directory information from NIS, which is a central repository, but we still have to create the home directories and make sure that the permissions are correct before we go on. So that was a good test of that. I'm gonna exit now, and since we're discussing permissions, I just want to cover permissions real quick. In Linux, basically everything is a file, and there are different types of files, and these files have permissions. So let's take a look, for example, our TMP directory, ls-lh, and when it comes to permissions, you will see these, when you do an ls-la to list all the files, you will see the permissions right here, and there's 10 of these fields. The first one tells you the type of file it is. If it's a directory, it will have a D. If it's a block or a disk, like ls dev sda1 ls-la, it will have a B for block. If it's a socket file, like for example, let me find a socket file, is var run dbus system bus socket. This is a socket file, see, and it has an S on the first field. So this basically tells you what type of file it is. If it's just a simple file, it will just have this, the dash. Now the next thing is the first, after that, the next three are the permissions for the user or the owner, which in this case is root, right here. Then after that, the next three are the permissions for the group, which is root is the group that owns this file, echotest.cc. And finally, the last three are for everybody else, so every other user, the type of permissions that user has. So in this case, for echotest.cc, we know that it's just a regular file because there's a dash. We know that the owner or root has read and write but no execute. Then the group, which is also root, has read and that's it, no execute or write. And then everybody else has just read. If we wanted to change the permissions, we could use the command chmod. And chmod takes basically a minimum three different numbers, and it also can take letters, but the numbers are easy to remember. 4 is for read, 2 is for write, and 1 is for execute. And so if you wanted to give read, write, and execute, you would add all of those, and that would be a 7. If you wanted to give read and write, it would be 4 plus 2 or 6. If you just wanted to give read, then it would be just 4. If you wanted to give just write, it would be 2. If you wanted to just give execute, it would be just 1. And then you have to pass at least 3 of those numbers. So 1 for each, the user or the owner, then the group that the file is owned by, and then finally for everybody else. So if I want to change and give this echo test file execute, give the owner read, write, execute, and then give everybody else read and execute, and then give the group also read and execute, I will run the command chmod 755 echo test.cc. And then if we do and check it, no, echo test.cc. See, now we've changed the permission, so it's still a file. The owner has read, write, and execute, or 7. The group, which is root, has 5, which is read and execute, 4 plus 1. And finally, everybody else also has read and execute, which is 4 plus 1. Now, there's one more thing with chmod that you can do, and that is to set the UID or SUID, or to set the group ID or SGID. And what this does is it allows, for SUID, it allows you to execute a file as a regular user, but with basically if it's set UID as the user that owns the file. So let's say, for example, that I have this file here, echo test, and this file is an executable. And basically what it does is I just compiled this simple C++ program. Let's take a look at it. This C++ program, all it does is it opens the file tmp-response.txt and it writes to that file. The only problem with that is if I run this as a regular user, that file is owned by root, and only root has read, write, and execute. Nobody else does. So if I run this command as root as a regular user, it's gonna fail because I'm trying to open a file that belongs to root, so it's not gonna work. So if I change the permissions of the executable to 0755 echo test, see, now the user, the owner root has read, write, execute, the group has read and execute, and the user has read and execute. So if I run this as the user student, it's going to fail and tell me that it's not able to open the file. And let's just check that, su minus student, and then I'm going to run it tmp echo test. See, and it tells me that it's unable to open the file, because that file, as we can see here, response.txt, the one that we're trying to write to, it's only root can write to it and student can't write to it. But let's say me as the administrator, I wanna allow student to be able to write to that file, and this is done. And a perfect example for this is the etc password. So the etc password is owned by root, and only root can write to it. If we look at it, only root can write, the owner. Everybody else just has read access. But when we change our passwords, the user actually has to go and modify that file. So how do we do that? And that we do that through the using the set UID. So let's go back to our example. Now I'm going to change the permissions and give set UID to this echo test. And to do that, you put a 4 before the permission. So you do chmod 4 and then 755 because I want the owner to have read write execute, and then everybody else just to have execute and read. If we put just 755, it assumes that 0 is the first number. But in this case, we've told it for 755, and that's what you do for set UID. If we were doing set GID, which is basically the same concept, but this time for the group to be able to run it as the group that owns the file, it would be a 2. And you could do 1, 2 for sticky bits. And sticky bits we really don't use anymore. That's to keep programs running in memory. And we used that in the past, but not anymore. So I'm not even covering it. So what I'm going to do is do chmod 4755 on echo test. And then if I do an LL, now you can see that for the owner, there is read write, and then under the execute there's an S. So there's a sticky bit set, or a sticky set UID set on the file. So now if I go ahead and su minus student and I run this command, tmp echo test, I don't get the error. And now if I put it in the background and do a ps minus elf in grep echo, I can see that this command is actually running. I ran it as the user student, but it's running under the root account, which is how it allows me to write to that file. So that's the nice thing about set UID. And like I said, set GID is basically the same concept, but this time for the group. It's nice and useful sometimes, but it's also dangerous and really insecure because hackers usually try to find files that have this so they can run different things as root and modify these files to put other commands there. So you have to be very careful when you use these two commands and you set these kind of permissions because they can really cause problems on your system as far as security goes. The last concept I want to explain is the umask. Let me create a directory on tmp umask. Okay, I created a directory. So if we go to tmp, we see that there's a directory there called umask, and it's a D for directory. Okay, the umask basically tells you the permissions that files created in a directory will have. So if I cd to umask directory and I run umask, it tells me that the umask for this directory is 022. What that means is that basically what you do is you subtract that from 777, and that's basically the permissions that files created there will have. So 022, if you subtract that from 777, is 755. So any file created here will have 755, or which means rewrite and execute for the owner, and then read and execute for the user and group. But one of the things in Red Hat 4, they've taken away the execute bit on the umask. So if I create a file here, touch test, touch just creates a file with a timestamp. So I'm going to create that file. If you look, it has read and write, but it took the execute out, and it took the execute here, and it took the execute here. So even though I specified that I wanted execute in the umask, it didn't do that. Now I can change the umask for this directory and do umask 7, let's see, 000. 000, if we subtract that from 777, it will give everybody, it should give everybody read, write, and execute. But again, it won't do execute, so we should see read and write for everybody. So let's change the umask to that. And now let's touch test 1. And see, we see that it gave everybody read and write, the owner, the group, and everybody else. again, it doesn't do it for execute anymore, and that's one of the things for security reasons that they took out on Red Hat for. Um, UMask won't go in and change files that already exist in the directory. It's only helpful and used for files that are created in that directory after you run the command. So that's something that you need to know.